we are going to talk now about vertex form. Let's say we have a quadratic, and the quadratic is graphed, and the vertex is here at 2, -3. If you can identify the vertex, you can write the equation in vertex form, and you can use that to write it in standard form. So we identified the vertex. Now sometimes the vertex is not given. You have to find it. You have to name it. So I'm telling you that the vertex is 2, -3. The vertex form for a quadratic is y equals a times x minus h squared plus k. We're going to write that down. Y equals a parentheses x minus h squared plus k. Our vertex is 2, -3. This is your h, this is your k. So what you're going to do is you're going to type in y equals, we're assuming that a is 1, x minus h is 2. So I'm going to put 2 squared. K is -3. So instead of putting plus 3, I'm going to put minus 3 because K is negative. Notice that this is the opposite of H. So if H is 2, in the formula it's going to be -2. Alright, so now we have the equation in vertex form. Once you have the equation in vertex form, you can go over to Desmos, and we're going to type in the equation y equals, move this over so we can see, x minus 2 squared minus 3. Alright, so here's the graph, and notice that the vertex is indeed at 2, -3. If we want to put this equation in standard form, so we're going from vertex to standard form, you're going to press the settings button, grab the table, click add regressions, choose quadratic, not quartic, and it will give you the equation in standard form. Here we go. You press settings, you go to table, click add regressions, change linear to quadratic, not quartic, and here's your equation in standard form. It is y equals x squared minus 4x plus 1. Now we have the equation in standard form. From this point, we can identify A, B, and C to find the solutions using the quadratic formula. Now, these solutions are not whole numbers. So this is why we need to use the quadratic formula to determine what the solutions are. A is 1. B is -4. C is +1. So we have discussed how to write it in vertex form, given the vertex, and we have discussed how to write it in standard form once you have vertex form. The next thing we're going to do is substitute this into the quadratic formula to find the solutions, written in radical notation, not as decimal values that are irrational numbers. Okay, A, B, and C, quadratic formula. The opposite of B, plus or minus the square root of B squared minus 4AC divided by 2 times A. Alright, the opposite of B is going to be +4, plus or minus the square root of B squared is 16 minus 4 times A times C divided by 2 times the A. You do not need to calculate 2 times a. You should know that 2 times 1 is 2. We also already have the 4. So we're going to bring down the 4, and we're going to bring down the 2, along with the plus and minus signs. So here, we're going to type in, let me delete this. We're going to type in the square root symbol, because what we're typing in is the discriminant. 16 minus 4, parentheses 1, parentheses 1. Oh my goodness, look at that decimal. Well, we definitely cannot put a decimal right here. So remember, you are going to backspace, delete the radical sign, and we get 12. That means that the two solutions are 4 plus or minus the square root of 12 over 2. We can check it because we've already put it in the calculator. I think we did. So let's do it again. Y equals x squared minus 4x plus 1. Okay, so I think that one of the solutions is 4 plus the square root of 12. And then I need to put this in parentheses because all of this is going to be divided by 2 times a, which is 2. I get 3.7. Alright, so I want to make sure this value is, that's not it. There it is, 3.7. So I know that that one is right. Alright, now instead of typing it again, I'm going to put a minus sign right there. I get 0.267. That's the same number. So I know that this is the correct solution. This is how we go from being given the vertex to writing it in vertex form, from vertex form to standard form. From standard form, we use the quadratic formula to find the solution so that it is written in radical notation and not with decimal values that never end.